So, good afternoon. Welcome to AT, Automation Technology, to the presentation with the title Discover AT's Game-Changing High-Performance Sensors in eMobility. This sounds really great, but what we mean is our unique technology for 3D, our really benefits and advantages regarding performance, means speed, resolution, dual head, and so on. And I will show you in the next slides some benefits what you have for applications here in eMobility, means hairpin detection, means battery inspection, and also pin inspection. So my name is Armin Jehle. I'm a sales manager in Europe at AT. I'm nearly 25 years in machine vision. A lot of the time, 15 years also at Cognex. And then I was also working for a system integrator of Cognex. And if I look to the last 10, 15 years, 3D got more and more important. And I always were looking to AT, because AT has what I need for customers, for projects, maybe to have more speed, to have a bigger field of view, more resolution, dual head, and so on. And since 3.5 years, I'm part of AT, and now I have it. And yes, and I will show you in the next slides what are the benefits. And here's some words maybe to AT. So AT is, maybe you heard it from some videos from our marketing. Hello from Bad Oldesloe. Bad Oldesloe is in northern Germany, located between Hamburg and Lübeck. And we are more than 25 years in machine vision area, especially for infrared and for RD cameras, and really a pioneer on the market. So now we are more than 50 people, and we are developing, producing, and selling special cameras in two areas. One is infrared, and the second one, the bigger one, is 3D. So I want to show some applications first here if in infrared. And you know, the production of batteries are not uncritical, also because of, maybe they can be burning, maybe there could be fire and so on. So on safety reasons for the machine as well as for the employees, and maybe it's forced by the fire insurance, you have to do and you have to inspect the batteries in the production that there is not some burning. So in this example, this is not a battery, this is a electronical part, but also you have to detect some hotspots. And you see on the top, you see our IRSX. This is a real infrared smart camera with your different resolution. And yes, you don't have to compare infrared with a standard 2D or 3D. You need less resolution and less pixel to detect the images. We have 360, 36 and also 630 pixels. And this is a web-based solution, means you don't need to install any software. You can directly use the IP address and then you come to the camera. And we have two versions, one with 9 Hertz and one with 30 Hertz. And important to know, with 9 Hertz means 9 images per second. This is really absolutely enough for battery production because it's not really fast. And with 9 Hertz, it's no dual use necessary. Dual use means you can use it also for military applications. And in this case, with 9 Hertz, you don't have any issues with export regulations and so on. So you can ship it to each country. Also, this camera is factory calibrated in a big range of -10 to 550 degrees. And it's really, really robust. Yeah? It's IP67. And you also have an air pure system. You see it here at the top. Means you blow air on it and you can clean the completely cover. At the end, you can install it directly at the machines. You don't need external housing or something else. You directly can mount it. You can connect it to the PLC, also for I/Os, to get the signals, the alarm signals, and so on, directly to PLC. And there's a special app and job concept, means you can make easy a job. I compared maybe like with Cognex, the inside. This is the infrared, you can say inside. You just have one job for each battery. You have different AOIs, areas of interest. You can look to this AOI for the min, for max temperature, for mean temperature. And then you can set some thresholds, maybe for warnings or also for alarm. If this area reaching some temperature, because means the hotspot is going higher, then you can set alarm signal and then, yes, to be safe that nothing happens. Here's some images. You see on the left side, you can inspect as well as cylindrical or rectangle modules. And this is an example on the right side. It's not a battery, it's an electronical board, but you see also the hotspot here, a special component is much higher And then you can detect it and say, okay, here's something wrong. And in battery production, yeah, you have on each machine, you have a camera, and then you can follow this battery if there may be some cylindrical module is really a different temperature. You can look if it's really got higher or maybe it could be normal in the next steps of the production. This is one application in the battery production. We have another applications here for a hotspot and early fire detection. You see on the image, these are buses, and you see at the back there are the battery. These buses are in the charging area, and maybe you heard in the news sometimes, yes, there was a bus was burning, and not only one bus, maybe the completely buses are gone in fire. So you want to avoid that, then to see if something happens, and then you can react. So this is some applications in infrared. Now we switch to AT, to the 3D area. This is a bigger area from us, and we always say maybe if you use once AT sensors, you ever will use AT sensors because we have a lot of benefits. We're always the fastest sensors, and with our new Imager 3070, we reach maybe another level, and we call it warp speed. It's standing for widely advanced rapid profiling. It's really next level of speed. And with our big range of imagers, we have 1280 pixels per profile, 2000, 3000, 4000 pixels, really big resolution to also achieve a big accuracy. We have opportunity of single, dual head, different wavelength, depending if there are more sensors that they don't influence each other, to choose the right depth of field of the laser, the laser line thickness. We can do a lot of things to get the right sensor for the application. Maybe here's some small, so image from a few sensors you see on the right side. This is just one camera. There you need a separate laser. You use it maybe if you have a really big field of view, a lateral, or you have a big distance. Then you have to calibrate the sensor by your own. But if a big portfolio of CS, it's called compact sensors, so more than 40 sensors multiplied with different laser options. So we have more than 200 standard sensors. Really a big portfolio. And out of this portfolio, we launched some new series during this year. One is maybe as an entry level, we can say this ECS, it's standing for economical compact sensor, means a lower price, and there you have just 2000 pixel. It's not the fastest, but still high speed, up to 25 kilohertz. And we just use the 2M laser in red. This means less safety regulations, laser safety in your line. And yeah, maybe this could be as an entry, and especially if you need more sensors. You see in some areas, in some markets like logistics, you need more than one sensor. So price is really important. This is the entry level. Then we come to the high-end level. We introduced last year our new imager developed by AT, and yes, produced for AT exclusively for sure. Normally you have an image, yeah, and then you transfer all pixels from the imager to the FPGA. This needs time. In our case, we have a pre-processing on the imager, means we are detecting directly on the imager the laser line. And then we transfer only some pixels around of this laser line from the imager to the FPGA. This is maybe 10, 20 times less information. This means also 10, 20 times faster. And with this new imager 3070 in combination with the new C6, which means a faster FPGA with double speed, in combination with the new I/O boards, we have a 2.5 gigabit and 5 gigabit per second to transfer all data from the sensor to the PC. Yeah, this is what we are calling warp speed, and it's standing for widely advanced rapid profiling. And this is really a revolution, and we say in combination of speed and resolution, this is the fastest sensor of the world. So this imager we can use also for our special modular 3D sensor. It's called MCS, and the MCS is a customized sensor. This means we can do the optimized sensor for the application. Customized sounds expensive, but there is no engineering costs or minimum order quantity. We just use of our portfolio, all components, to build the right sensor. And MCS has at least here a sensor module with the imager, with the optics, FPGA, Scheinflug, and so on as well. And then the second module is the laser module. And then we have an MCS configurator, and then you can insert all specification of the application, like the working distance, the field of view, what you need, the triangulation angle, and then you get out a sensor. Could be like this here with maybe with a spacer in between, with no spacer. The bigger ones are carbon tube, the smaller are metal tube. You can say you press a button, you have a dual, then you have 2 sensor modules and 1 laser module. Means at the end, you get really the optimized sensor for your application with the best results. And for example, in battery application, we see very often you need maybe a bigger field of view, and the customers are using a sensor and going to the far field. Far field means you're out of focus, and also means the results are not really the best. So in our case, we always have the right answer and the right sensor for the application. So this was the MCS, and out of this MCS, we created a new series. It's called, yes, XCS. X was standing for extreme or excellent. We used an MCS and optimizes MCS here optically and only with the 3000, 4000 pixels. With the warp speed could be really fast, but really high resolution on a small field of view. Now the field of view is nearly 50 millimeters. So high resolution, high accuracy on a really small area. And with the new laser technology, there we're using a special laser with a clean beam technology. And at the end, you get a really thin laser line, blue laser line, to inspect, for example, BGAs, ball grid areas in electronic, or this pin grid area, or as well as for pin inspection or for hairpin inspection, eMobility. So this is maybe the high-end sensor, and it should give you a short impression how, yeah, sensors we have, and we always have the right sensor for the applications. And this is one part to get an image. And we say maybe in the past, we for a turnkey solution, for me it's always like a puzzle. And AT provided one puzzle part. This was the 3D triangulation sensor, and yes, just for the image. For sure, the image is the most important part, because if you cannot see in the image what you want to measure or what you want to inspect, the best software will not help. But then you get an image, and then you start maybe third-party libraries. It could be, for example, Cognex Vision Pro and also the VD for deep learning, Halcon, Matrox, and so on, and then you start your application. Last year, we launched our solution package, and especially there's a metrology package in it. We have some tools and also some helpful tools for calibration and so on. And then you can make, yes, your own application. It's still a PC-based solution. This means this is not a smart camera. We still have a sensor, and you need a PC, and the software is running on the PC. But with that, it makes it really much easier to get the application and the solution running. So just to get a short impression, this is the Metrology Explorer. And yes, we say in 10 minutes, you get an image. You see all sensors which are in the network. You can connect to a sensor. And then there are all parameters which are necessary to get a really fast image, like exposure time, gain, to use the encoder and where the trigger is coming from. And then you get really fast an image. And we have a lot of samples and applications. Then you can start scripting. And some really important parts are maybe to get the source code out of that. And then you can use the source code in other software, and you have a completely solution. One highlight is the multi-sensor registration. I showed a lot of dual head before. Dual head means you have 2 sensors, you have 2 images. In this case, there are 2 sensors mounted as a V with 2 different laser colors, but you get 2 images. No? And here you see a calibration target, what we also provide. And at the end, you get 2 images from 2 sensors. And with our multi-sensor registration, you quite simply get 1 point load out of several sensors. Could be 2, as in this case, could be 4, could be 6, but don't care. And everybody who is developing software and doing the registration and calibration knows it could be really, really complex. With this tool, it makes it really quite simple. We can use it or can do it by your own. And then, as I said, we have the software of the images, and then we can work maybe with Cognex Vision Pro, with VD to do the complete inspection. So this will give you impression. I want to show some applications. It's normally it's quite difficult to show some images out of the production, because yes, it's maybe a gold rush in eMobility for electrical engines, for batteries. So a lot of big of competition. So yes, it's yeah, I have some images to explain what we are doing here. So in this case, there was a battery inspection. Means we have to measure the battery box as well as the modules. And yes, we choose 3 MCS sensors, and these are optimized in the field of view. You need a bigger field of view, optimized in the working distance as well as in the laser. At the end, these sensors are on the robot, and you're going over the battery boxes as well as the modules. Another application is for laser welding, means you have to detect the modules, could be like this, rectangle or cylindrical, and you have to find here the anodes and cathodes to detect the position, and then you're positioning the welding laser to do the welding, and also we can inspect after that the welding points. Next application is from hairpoint inspection with our partner AKU, and they had a solution, but yeah, customer said this solution it's not fast enough. We need a faster sensor. They come to us and say, okay, we can use a modular compact sensor and with a better speed. And I say, oh yes, there is also some problems with shadowing, with occlusions. Then we choose a dual head. They have some problems to go in the gaps in between, so we're using a smaller triangulation angle. And then they say, okay, we need better results, more accuracy. We do the high resolution. We do the high resolution, and still the sensor was faster than before. But at the end, they're the optimized MCS sensor, so the best solution for this application. And AKU is also using Cognex Vision Pro after that to do the results and do the inspection. So another application also in hairpin from our partner SenseWork. So SenseWork are using 2 sensors, standard sensors, and optimized in laser depth of field. We're using 2 different laser colors, blue and red, and to detect the hairpins. And you see some result images. So, and they don't have to inspect only the welding point at the top, and also to see on the side how many material is here between the different hairpins to make sure that it's really a good combination. The next application is for our partner Harand or the Harand Feinwerktechnik. They also have an application starting up here. So you see to inspect each hairpin. They're doing the assembly of the stator, like you see here, and then also we do start the inspection of each hairpin before and after the welding process. And here you see one image, and here they need really high speed. We choose the 3070, the new imager with warp speed as a dual head, and also they have here some problems to see the gaps in between. Also, then we build a new sensor with 15 degrees of triangulation angle to go also through the gaps. So at the end, yes, they have what they need: high resolution, high speed, and a small triangulation angle, and it was really the optimal sensor for them. And last but not least, I have no video from the battery production, but I show you a video here is for metrology application for car bodies or car parts. You see there's a modular compact sensor, and we're doing not only gap and flash measurement as well as for surface inspection. And here is done with 4 robots and for the complete car body. And you can imagine we can do it with a car body. We also can do it with a battery. So this was really fast and powerful. Yes, AT is standing for these values. So if there are some questions, it's your chance to ask me that.